It's Mr. Whitehead, ready for your maths lesson. You're going to need a couple of things, pen or pencil and some paper, and your practice task from the last lesson. Press pause while you get your things together and come back when you're ready. Let's take a look at the task. Can you hold it up for me so I can see how you got on with those 3 problems from last lesson? Looking good. Let's take a look at each part. So, 4 inequality symbols to fill in. I've left the generalization from last time on the page. Give it a read with me. 1, 2, 3. When comparing unit fractions, the greater the denominator, the smaller the fraction. Did you keep that in your mind while you were solving these problems? Let's take a look at what the missing symbols are. Greater than, less than, less than, less than. Is that what you got? Wait, which one? The last one. The last one's not right. 1/7 is less than 1/12. When comparing unit fractions, the greater the denominator, the smaller the fraction. So it should be 1/7 is greater than 1/12. Good spots. Second part, arrange the following numbers in order. So again, the generalization is there. That's what I was thinking about as I was ordering the fractions. And this is what I got. 1/3, 1/7, 1/9, 1/10, and 1/15. Is that what you got? You didn't. When comparing unit fractions, the greater the denominator, the smaller the fraction. So I've got my larger fractions on the left, and they get smaller. 1/3 is the largest, and they start to get smaller. Why is that wrong? Look at the question, Mr. Whitehead. Arrange the following numbers in order from smallest to largest. So is this what you've got? Is that better? Fantastic. Thanks for your help. Third part. So we have 2 inequalities, 2 statements to complete with missing denominators. What did you get for 1/6 is less than something? Say it again. There's lots of options. How many options are there though? How many different denominators could we fill in? So 1/6 is less than 1/6 is, so it couldn't be a denominator of 7. It couldn't be 1/7 because 1/7 is smaller than 1/6. So the denominator has to be 5, 4, 3, or 2. Any of those as your denominator would be correct. How about the second one? 1/something is greater than 1/8. So again, what could the denominators be? Tell me what you got for this one. Say it again. Again, I've had lots of different options, but how many options could there be? How many do you think there could be? What could the denominator not be? It couldn't be a denominator that's greater than 8, a larger number than 8, because then 1/9, for example, is less than 1/8. So the number has to be smaller than 8. So it could be 1/7, 1/6, 1/5, 1/4, 1/3, or again 1/2. Any of those would be correct. And well done if you were able to spot how many possibilities there were. Right, this lesson. Up until now, we have been looking at unit fractions and comparing unit fractions. But what is a unit fraction? How would you define it? Tell me. Good. A fraction with a numerator of 1. So in this lesson, we're going to be working with non-unit fractions. If that's what a unit fraction is, what would you change in the definition to give me a definition for a non-unit fraction? What would you change? Super. A non-unit fraction is a fraction with a numerator greater than 1. So today, in this lesson, we're going to be comparing non-unit fractions. We'll be using our symbols greater than and less than. Here's our first problem. Now, let me tell you, the problem has been solved. Your task is going to be to prove it is correct. What does it mean to prove something? You're going to give me some reasons. You're going to be giving me some evidence, some proof that what's in the problem is right. Let's take a look at it. Can you read it with me? Izzy and Olivia each have an identical juice bottle. Identical, the same. Izzy's juice is 2/3 full. Olivia's juice is 2/4 full. Izzy has more juice than Olivia. Suggest ways to prove that 2/3 is greater than 2/4. Now notice the fractions. In previous lessons, they were unit fractions. In this lesson, they're non-unit fractions. Why? Because they have numerators greater than 1. What else do you notice about those fractions? Yes, they are non-unit fractions, but what else do you notice? Good. The denominators are different, but the numerators are the same. They're both 2. Okay, in a moment, press pause. To support your thinking, as you give me some proof that 2/3 is greater than 2/4, in previous lessons, you have used diagrams, number lines, and verbal reasoning. At least one of these, please, at least one of these, use to give me your proof that 2/3 is greater than 2/4. Challenge yourself by using more than one piece of evidence, by using more than one method. Press pause and come back when you're ready. How did you get on? Anyone use method 1, a diagram, to prove that 2/3 is greater than 2/4? If you used a diagram, hold it up for me. Let me have a look. Looking good. You're showing me 2/3 is greater than 2/4. Here's mine. I started off my diagram making it look like a bottle, because of course it's about juice, isn't it? We're comparing amounts of juice. So one bottle divided into 3 equal parts and the other into 4 equal parts. There's Izzy's juice, 2 of those equal parts, and Olivia's juice, 2 of the 4 equal parts. And we can see Izzy's juice is greater than, there's more of it than Olivia's. Now I noticed some of you used circles. For one of the circles, we've divided it into 3 equal parts and the other circle into 4, and we're going to represent 2/3 and 2/4 to help us compare and again see which of those fractions is largest. Of course, 2/3. How about method 2? Who used a number line? Hold it up for me. Let me take a look at your number lines. Super. 2 number lines, the same length, because we're comparing 2 fractions that represent an amount of liquid, an amount of juice in the same sized bottle. So the space between 0 and 1, I'm dividing into 3 equal parts on one number line and 4 equal parts on the other number line. I can represent 2/3, 1/3, 2/3, and I can represent 2/4. And as I look at my number lines, I can see 2/3 is closest to 1, and it's the furthest from 0. What do you notice about 2/4? Is it closer to 1 or to... It's halfway between 0 and 1. However, 2/3 is closest to 1. It's furthest from 0. It's the greater fraction. Method 3. Now, verbal reasoning. Using your words to explain. So maybe you wrote down a few things to help you with this. And what I'd like to do now is show you a way of structuring the sentences you use to give your evidence. Let me show you. 2/3 is 2 lots of 1/3. Can you fill in the gaps on this sentence for the other fraction? Say it. 2/4 is 2 lots of 1/4. Now, we already know, comparing 1/3 and 1/4, that 1/3 is greater than 1/4. We know that because when comparing unit fractions, the greater the denominator, the smaller the fraction. And if we look at our containers and our juice in those bottles, we can see 1/3 is greater than 1/4. We know that already. So, I know that 2 lots of 1/3 is greater than 2 lots of 1/4. I can compare fractions that have the same numerator using what I know about unit fractions. And I can explain that verbally, like I've just done. 2/3 is greater than 2/4. So our 3 methods: diagram, number line, and verbal reasoning. Is there one that you think was easiest for you to use? Smartest for you to use? Is there one that you found more challenging? I've got another problem for you. Push yourself again, this time, when you pause, to use at least 2 of the methods and try to make one of them verbal reasoning. True or false? So this time, you need to solve the problem and tell me if what's in the problem is true or false, but again with some proof. Give the problem a read with me. Sam and Jay are both reading the same book. Sam has read 4/6 of her copy. Jay has read 4/5 of his copy. Is it true or false that Sam has read less than Jay? That 4/6 is less than 4/5? Again, press pause and, like I said, push yourself to using at least 2 methods to prove whether this is true or false, and try to make one of those methods method 3. Give me some verbal reasoning. Press pause and come back when you're ready to take a look. How did you get on? Who had a go at method 1? Hold up your diagrams. Show me the diagrams you've used to show me whether or not it's true or false that 4/6 is less than 4/5. I see some circles like these. I see some rectangles as well. Okay, let's have a look. So one of these circles is representing 6, divided into 6 equal parts, and the other into 5 equal parts. I am going to represent 4/6 and 4/5. I can see 4/6 is less than 4/5, so it's true. Some of you used rectangles. Again, you divided your rectangles into 6 and 5 equal parts. And we're representing 4 of those 6ths, 4 of those 5ths, Now, when I looked at these rectangles next to each other, side by side, it was a little bit difficult to see which one was greater. So we can also arrange them like this, vertically, and we can clearly see that 4/6 is less than 4/5. It's true. If you had a go at method 2, hold up your number lines for me. Are those number lines equal in length? Have you divided one of the number lines into 6 equal parts and the other into 5 equal parts? And have you marked 1, 2, 3, 4/6 and 1, 2, 3/5, 4/5 on your number lines? So how does this help you to say whether or not it's true or false? 4/6 is closest to 0. 4/5 is furthest from 0, or we could say 4/6 is the furthest from 1 out of the 2, and 4/5 is closest to 1 out of the 2 fractions we're comparing. The diagram and now the number line have proved that it is true. 4/6 is less than 4/5. Now, I did challenge you to all have a go at using verbal reasoning. Here are the sentence stems to help you again. Can you join me from the beginning in using verbal reasoning to prove whether 4/6 is less than 4/5? We know it's true already, but let's have a go with our verbal reasoning as well. Okay, so 4/6 is 4 lots of 1/6. Good. Second fraction, 4/5. Ready? 4/5 is 4 lots of 1/5. Super. Now let's use what we know about unit fractions. I know that something is less than something. Ready? I know that 1/6 is less than 1/5. How do we know that? On the number line, 1/6 is less than 1/5. And with our generalization, when we compare unit fractions, read the rest of the sentence with me. The greater the denominator, the smaller the fraction. 1/6 is less than 1/5. So how does that help us with 4/6 and 4/5? So, ready? 4 lots of 1/6 is less than 4 lots of 1/5. Look at the number line. 4/6 is less than 4/5. Fantastic. So we have used 3 methods, a diagram, a number line, and verbal reasoning to compare non-unit fractions. Although those non-unit fractions, of course, have the same numerator. For your practice activity to have a go at before the next lesson, I've given you 3 statements to compare and to fill in the missing inequality symbols. The challenge, that needs you to think, when the denominators are larger, which method is the smartest to use to help you to compare the fractions and why? So we've used diagrams, number lines, verbal reasoning. But for those, for example, in 2 and 3, for those large denominators, which of the methods is the smartest to use? I've left on the screen as well the sentence stems that we were using to explain verbally, and the generalization that we were using to compare unit fractions. Use those to support your thinking as you solve your practice activity and challenge yourself as well if you're ready. Well done for working so hard on this lesson where we've been comparing non-unit fractions. Press pause, take a copy of the activity and have it ready for the start of the next lesson. Bye.